Hello students, welcome back to another video. Today we're going to continue talking about the electric force. More specifically, we're going to talk about how we can calculate the electric force between two stationary charges. The law that we use to find the force between two charges is called Coulomb's law. Okay, so once again, the Coulomb's law is the law we use to calculate the force between two stationary charges. Before I get into the equation, I want to discuss the variables that determine the strength of the electric force. There's two variables here. The strength of the two charges that are attracting or repelling each other, as well as the distance between those two charges. The closer they are, the stronger force they feel, and also the greater the charge, the greater the force as well. So now I'm going to show you what it looks like in the equation. Right, here's my equation for Coulomb's law. I'll go ahead and explain each variable now. So Fe is just the electric force. This K here is a constant. It's called Coulomb's constant. This constant is just a number that doesn't change, but it's always going to be here in the equation, so it's important to include it whenever you're doing math with Coulomb's law. Coulomb's constant, K, is equal to approximately 8.99 times 10 to the 9 power. Okay, so once again, K is equal to 8.99 times 10 to the 9 power, and the unit for Coulomb's constant is Newton meters squared per Coulomb squared. You shouldn't worry too much about the units, but you are going to have to use this number in the equation whenever you're calculating force. The next two variables here, we have a Q1 and a Q2. These two Q's are the respective charges of the two charges that are interacting with each other, producing this force that either repels or attracts those two charges. Okay, so both these are charges, and they have units of coulombs, which we use a capital C to notate. These charges can be negative, they can be positive, depending on the situation and what charges are interacting. If one charge was negative and one charge was positive, a negative times a positive creates a negative, so that means that the force between them would be negative, which just means that they're going towards each other. If they are both positive or both negative, that creates a positive force, which means that they have a force away from each other. The last variable down here at the bottom is R, or radius, which is just going to be the distance between those two charges. Okay, because R is a distance, it's going to have units of meters. And I forgot to mention that because we are dealing with force here, the unit for force is a Newton. Okay, so altogether we have our equation for force given by Coulomb's law says that the electric force is equal to K, which is Coulomb's constant, times Q1 times Q2, the two charges, divided by R squared, or the distance between those two charges, squared. If I were to try to calculate the force in a particular example, and I know the two charges, and I also know the distance between them, all I have to do is just plug the numbers into each spot here, and then use the calculator to find the force. I'm going to erase these labels to go through a really easy example. Let's say I'm given a situation where I know Q1 is equal to 1 Coulomb, Q2 is equal to negative 1 Coulomb, and R is equal to 2 meters. If I wanted to find the force, I just have to plug these numbers here, as well as a constant. Okay, so I plugged in my numbers here. My K constant is 8.99 times 10 to the 9 power. And then my two charges are 1 Coulomb, negative 1 Coulomb. So I'm just multiplying those together, and then dividing all of that by 2 meters squared. I know 1 times negative 1 is just going to be negative 1, and negative 1 times this constant is just going to be the negative constant. And then I know 2 squared is 4, so it's just going to be negative 8.99 times 10 to the 9 divided by 4. Okay, when I plug this in my calculator, I get negative 2.25 times 10 to the 9 power newtons for the force. Now I'm going to go through some examples that relate to this week's weekly assignment, where let's say we know what our force is, but then we change the charge or the distance, and I want to know what does that change do to the force. This week's weekly assignment has you figure out how these variables affect the force. The first activity has to deal with changing the charges, and the second activity has to deal with changing the distance, and then the third activity puts it all together and changes the charges and the distance. And you are supposed to calculate the new force when you are given the old force and then what changes happen with those variables. Okay, so let's say I have two charges at a certain distance, and I know that with that system, the force between those two charges is 10 newtons. Okay, and then let's say I want to double charge 1 and see how that affects the force. Okay, well, since charge is directly related with force, if I multiply 2 to this side, in other words, if I double one of the charges, then whatever I do to this side of the equation, I have to do to this side of the equation to keep it balanced. So I've multiplied 2 to this side as well. So because I have doubled a charge On this side of the equation, I have also doubled the force. I know 10 times 2 is 20 newtons. So my new force, because I doubled the charge, is 20 newtons. And that would be my final answer for that question on the weekly assignment. Let's say instead of doubling the first charge, I tripled the first charge and then halved the second charge. So that would mean I multiply by 3 for the first charge, and then because I halved the second charge, I had to divide by 2. Since now I'm multiplying 3 and dividing by 2 over here on this side, I have to do the same thing to the other side. I know 10 times 3 is 30, and 30 divided by 2 is 15. So if I triple one charge and half the other charge, I'm multiplying by 3 and dividing by 2 to my force, which gives me a final answer of 15 newtons. I hope that helps you get a good idea of how to go about doing the first activity on the weekly assignment, where you're just dealing with charge. The general rule of thumb here is that whatever happens to the charge happens to the force as well. If you double a charge, you double the force. If you half the charge, you half the force. They're directly related. Now I'll show you what happens whenever you manipulate distance. Okay, just to be consistent, I'm going to still go with my force being 10 newtons. But now instead of changing the charges, I'm going to change the distance. Let's say I know that between these two charges, the force is 10 newtons at this particular distance. But then I want to double that distance. Doubling the distance is effectively multiplying r by 2. So here I've added a 2 times r in parentheses. So I'm going to double the radius before I square it. So on this side of the equation, I'm dividing everything by 2 squared. And whatever I do to this side of the equation, I have to do it to the other side as well, for the same reason. I need to keep my equation balanced. Okay, so I'm also going to divide the force by 2 squared. So if I want to know my new force, it would just be 10 divided by 2 squared, which is 4. So 10 divided by 4 is my answer. Okay, and 10 divided by 4 is equal to 2.5 newtons for the new force. Okay, which makes sense, right? Because whenever the distance gets further from the two charges, the force gets weaker. Now we'll do an example where we, instead of doubling the distance, we cut the distance in half. Okay, so if we half the distance, then we have to multiply r by 1 over 2, or divide r by 2. And now on this side of the equation, I'm dividing by 1 over 2 squared. So I need to do the same thing on this side. So now I have, on the left side of the equation, 10 newtons divided by 1 over 2 squared. And it's very important that whenever you're doing this in the calculator, that you put parentheses around that fraction in the bottom. Having those parentheses makes sure that your square only applies to that 1/2. Alright, and 10 divided by 1/2 squared is equal to 40 newtons. Okay, so whenever I bring those two charges closer together, they feel a stronger force. Okay, so the general rule of thumb, whenever you're changing distance, the new force is going to be equal to the old force divided by the change in the distance squared. I've written that out here for you now. The new force is going to be equal to the old force divided by the change in the distance squared. So like whenever I halve the distance, I would take that force it gives me and then divide it by 1 over 2 squared. Whenever you're changing charge, it's more simple. As we were discussing in the previous examples, whatever happens to charge happens to force. So if I double a charge, I also double the force. Okay, I hope this video helps you guys get through the weekly assignment and understand how you can calculate the electric force using Coulomb's law. That's going to be all for today's video, so thank you guys and I'll see you next time.